Hey folks, sorry to interrupt the conversation. We're going to get started in about 30 seconds. Heads up. I wonder if they could pick up on the mic what I'm saying here. Good, thank God. I forgot that was on. I was still talking.
We will see everything is showing right here.
That's what you're seeing, yeah.
But I don't think you see before.
No. Well, I can make it larger here.
I want to read stuff on the screen. Would I see the text? Yeah, make that bigger because we don't. I don't know. This is helper text.
Yeah. Cool. All right, grab a seat. Alrighty, folks. We're going to move on to our next session. Again, I just want to say thanks to Steve Shedlock. That was an outstanding presentation, and we appreciate all your questions for Steve as well. I will remind you that these are not being streamed live. They will be available, made available after the conference at some point. But for now, we're going to move on to our second chat of the day. I'd like to welcome to the stage Uma Reddy and Anadi Sharma from Uptycs.
Thank you, Harry. My name is Uma Reddy. I work at Uptycs. I'm responsible for product and engineering at Uptycs. And I have Anadi with me. Anadi is a software architect. He does a lot of work on the Osquery side. Today we're going to talk about how Osquery extensions can be used to solve really complex problems. What people realize is, okay, Osquery, yeah, you run a query, you get data, you collect it on a periodic basis, and you can do a real-time query. Yeah, it's a visibility tool, maybe some insights. But what people don't realize is with Osquery, you can really solve complex problems, which even the vendors you have out there today, security vendors, really cannot accurately solve the problem or without false positives. So we'll give you an example of the vulnerability which all of us are familiar with, which happened in December 21. And we will walk you through how Osquery extensions came to the help and how it actually pinpointed exactly where you need to pay attention to, not look all through your file system for every single place where is that particular package exists, but the only ones which are really vulnerable. That's the thing to pay attention to. So, Anadi, do you want to talk about the extensions a little bit?
Yes. Thanks so much. Okay, so Osquery extensions actually leverage on the fact that Osquery itself is a very extensible and very configurable framework. And with extensions, you can add on additional functionality. You can extend Osquery to solve those problems, as Uma said, which are really complex, which are not always a part of the platform. And then you can, there are niche problems, right? You want to see what classes are there in a Java package, or what Java packages are loaded by Java processors. And those are some things which might not be a part of the actual Osquery solution. And they don't make sense here either. And so extensions come to the rescue because you can very quickly deploy something that just asks the specific questions that you're looking for and plug them into the Osquery framework and solve specific problems. Like in a parallel universe, you might want to know what .NET assemblies are loaded, or what jar files are running, and stuff like that. One advantage of extensions is that they integrate seamlessly with existing Osquery queries. So you can run the time query, as Harry said, and plug it into your extension and do amazing things with it. And similarly, extensions are good because you can write them not only in C, C++, but also in Python and Go. So you don't have to really learn C, C++ to write extensions. And then you can have experimental, something that you want to do with Osquery, but you don't want to break it. If something crashes, only the extension process crashes, so you can do some experimental development with the help of extensions and see how that experiment is going to look like when it becomes a part of Osquery. How do they work? So extensions, basically, as I said, they run as a separate process, which means that if you break the system, you only break the extension. You break the extension process. You don't break the worker process. You can take all the memory you want, but then Watcher will come in and restart your extension. If it takes more memory or more CPU than the Watcher limits permit. And but it also takes advantage of everything good that the worker has to offer, and that happens via the remote procedure call that happens between the worker and the extension processes. So you get the best of the both worlds and get your extensions to do what you want them to do. And of course, there is a registration, and then there is a RPC that's involved between the worker and the extension process. Compiling extensions, sorry, go back to the previous slide. Yeah, so to compile extensions, what you need to do is just take the open source Osquery, and then you take the SDK. So open source Osquery gives you the extension SDK, and then that SDK has header files and other components that become a part of your extension build process. And then when you compile your extension with the SDK components provided by open source, the Thrift IPC stubs get stuck to your binary, and you don't really have to do a lot of work. You just have to write the business intelligence there and write the register function, just register the classes that implement the business logic, and everything is taken care of behind the scenes. And there's a lot of boilerplate code out there that you can look at and write an extension, find out what the time might be in Australia right now, and write an extension. And so we really like extensions and how they can be used to to solve difficult problems. And Uma is going to talk about how we did that with the Log4j vulnerability. Thank you.
All right. I don't know how many of you remember the 10th of December, 2021, right? That was the day Log4j came out, right? At 10 a.m. in the morning, our meetings pulled out and said, hey, this is a problem. Now we got calls from our customers saying, how can you help us right away? Right? So we looked at, everybody was on deck, and they say, how do you solve this problem? And looked at so we looked at Osquery and looked at what the Log4j problem was about. So you look for a jar file which has a specific version of the Log4j core jar file. If it was less than 2.14 or less, you were vulnerable. And immediately we looked at the production data, and you could really see it happening, because you see in our own production cloud, our Nginx logs were constantly outputting those strings which people are using. So everybody was doing it. We were using Nginx. We were safe. There was no Log4j, so we were protected. But then a lot of our customers using Apache and others were vulnerable. So now, typical vulnerability management software, look at package versions and say, okay, this package is greater than this package or less than this version, so you're vulnerable. It was not that easy here. And then you just look, if you just traditional scanners, you scan your disk, and you say the Log4j jar is all over the place. Right? It isn't found in many, many folders. So now, how do I prioritize? Where do I fix? How do I get started? It's already being exploited today by threat actors. The first thing was you could shut your network off for some time, as long as your business will allow it, so that nobody else could come in, and then take your time to solve the problem. But then we said, okay, we can do something clever with Osquery, because if you could, with Osquery, you can do very smart things. We call these smart indicators, right? Osquery can give you deep visibility into anything happening in the operating system. So now I can write an extension and go in there and look at the files, the processes running, Java processes, see which of them have a jar file open, and see if those jar file actually contains the Log4j core jar file. Look at the metadata there to say, what is the version of the jar file? Is it 2.14 or less? And then actually, you can go even further and say that, does that jar really have the JNDI.lookup class? One of the first things folks started doing was go and pull that JNDI.lookup class out. And majority of the cases, it was of no use. It was just sitting there in the class. Nobody was using network communications to use that class anyway. So they pulled it out, repackaged the jar, redeployed the container, and they were safe. But they were still running 2.14 version of the Log4j jar. Now, our customers, when they pull out a traditional report, also the problem with traditional scanners was if you had 10,000 hosts, you go in as fast as you can go one by one, or in parallel, how many other threads you can run, pull the data out. It took days to gather the data. And then you mostly got garbage and developers leaving jar files in there, which is nobody's running any program which uses that jar. So what we did, we'll talk a little bit about the jar files. Then he said, okay, jar, no, there is a var format, there's a jar format, var format, year format. So there are multiple formats of jar files. Now you have to look at each of these. Traditional scanner could never do this. So a jar is an archive format where you archive the different classes together along with the metadata to go with it and create a jar, which is used in the Java program. That is the jar, and the next one. And we also have the var files. It's essentially a collection of various jars together and put into another file called var file. Now, it's not sufficient to look at a jar file. You have to look at a var file. And then you had shaded jars where you pull out all the classes you need, package them all together into one large archive, and that's your shaded jar. And then there is year files. So not just jar, you have to look at all these 4 different formats of files and look inside and see if you're vulnerable. And the year is a collection of var files, right? And then we looked at, we have Java developers in-house, so we use Java internally. So the developer said, here is how it looks like, right? Osquery developer, look at this. This is what you would find in a jar file. You would look at the POM file, and what you see there is that you see the version number, like it says 217.2, and it says the package, the bundle name, Apache Log4j core. So look for that, right? You need to go in the jar file, look at that metadata, look at that information, and return that in a table in Osquery as saying that when you say select star from this table, Java packages table, and give the var file or the jar file as input, it's going to list all of the bundles there and their versions. That was one query we developed. So once the Osquery developer saw that this was a format, sure, I'll develop a query to do that. And so we developed a query to go pull that out. And all we needed to know was how a jar file or a var file is structured, which our Java developers helped in writing. This is some additional detail on the metadata. Now, so we went ahead, wrote an extension. So we saw that out of the box, there was nothing in Osquery to go look inside a jar file. So what we did was develop an extension to determine the version and look inside and see if a JNDI lookup class is present in that particular jar file. And that's all we had to do. And then deploy that extension to our collection of servers. So here is what that extension did. It went and first enumerated all of the Java processes running. And then it found which of these processes had jar, var, or year files open. It's all very simple, trivial queries in Osquery. Select star from process open files where exe name equals Java and the path ends in var, year, or jar file. And once that happens, you got the jar file name. So you took that and fed it into the new table we wrote, Java packages table. So here is a jar file, Mr. Java packages, tell me all the contents of that. So then that was a new query we wrote in Osquery. It returned a list of all the Java packages in that jar file. So once you have that, you saw your version. Then you could run another query to go and take the subset of those jars and say, does this jar file have the JNDI lookup class? And then it came back and said, yes, it does or does not. So you have a complete in-depth answer, give you a prioritized list of all of the jars and what you have to take care of right away, which host has what open, shut off the process or go in and fix that particular jar or war. Do that first, and then when you have time, you go in, scan your entire disk, and get rid of all of the developer left jar and war files in your file systems. So, next one. I'm waiting for my demo slide to load up. Hold on. Where's the video? You going to can see it there? Okay. We finally wrote one query which found all the running processes which have war and jar open, and which of those jars and wars have a JND or lookup class inside them. So now with that one query, we could accurately point out where to go and fix. Now, Osquery also helps in scaling this out to tens of thousands of endpoints or even millions of endpoints. All you do is take this query, put it in a query pack, and then use your fleet management software to push this query to all of the endpoints. Typically, when you have a fleet management software, the endpoint checks in periodically every few minutes once, and you give it the configuration. And then it runs the query on the query pack on the endpoint. You collect all that data in the cloud in the fleet manager. Then you feed it into your SIM or wherever, and you immediately have a report. So the beauty is, in 15 minutes, you could do 10 endpoints, you could do 1,000, you could do 1,000,000. It's the capacity of your SIM to ingest all that data and then process it. So now there are commercial solutions out there which took days to do the same thing, because if you have 10,000 endpoints, 100,000 endpoints going on after them in parallel, scanning the entire disk and then getting a lot of garbage back, which you really don't have to pay attention to immediately, but they didn't have a way to prioritize. So some of our customers used our way of detection, this way of detection, to kind of prioritize. And this is fully supported in open source Osquery. All you have to do is write an extension, have a C++ developer, have someone who understood Java to help you do this. And then you understand query packs, distribute, and then report on them. As simple as that. And then we were pleased, but this whole thing was such a moving target, 2.14, 2.15, 2.16, 2.17, 2.17.1, 2.17.2, and then all you have to do is go and change your query. Right? Now, on December 14th, it was 2.5, I think it's 15, right? And then, so you just change it to 15 or less, then it to 16 or less. And so it was a very quick way to change. And you again run it in 15 minutes. You run the query through a distributed query pack, and you got the answer back. So you're up to date within a few hours of somebody announcing a new way of how 2.16 is vulnerable. You are able to detect that. So this way, the perception that Osquery is a tool for visibility or getting some little bit of metrics and data is people don't understand that this can stack up against the big vendors out there in vulnerability management or threat detection. Right? So, sorry, I was not moving my slide here. So you build a query pack, you collect the responses, and you report on it. All this could be done in 30 minutes across 10,000 nodes or 100,000 hosts. It doesn't matter the number. And come January, February, I don't know when this more vulnerability. Now Java is such a mess, right? Everybody, every day you're finding new things, but now we built one tool, Spring Shell, Spring Cloud. It was just a matter of hours for us to first understand what Spring Shell and Spring Cloud is about and be able to find the vulnerabilities, how to detect these. So once you built that tool, ability to look in the Java packages table, now you have coverage for all of Java vulnerabilities that are going to come in the future. There are some variations. One of these required you to find the version of Java running. That's very interesting. It's not found in the command line. You need to find the version of Java. It's 8 or I don't remember. But so there are some extensions we had to make in the Osquery extension to accommodate that. But basically, you have a good base for Java vulnerabilities going forward if you took this extension approach and built it yourself. It's quick to do. You don't have to worry about your endpoint performance being impacted because you're doing this in a hurry. It's a process which runs along the side, and if there is a problem, that particular process crashes or nothing to do. Your primary OS query is not impacted in any way, any significant way, right? And then what do we do? So what we have done is we've taken this code which Anadi built and put that extension code out in our Uptycs lab repository. You can go and click in that, download this extension code and use it and give us feedback on how it works. The point here we're trying to make is the model of Osquery and extensions is where the power of Osquery comes from, right? You have a process which, in extensions, you can write any code you want. So you're a software developer, you can go and find anything in the operating system and return it back in a query pack back to your SIM and then do your analysis. So that's, I think, so that's what we wanted to talk about. Happy to take any questions.
Thank you very much, Uma and Anadi. We'll take a couple of questions if folks have anything for Uma.
Since it felt like time stopped and started at widely varying degrees in the middle of December, what would you say is like the round trip time between when you decided like, hey, maybe we can do this in Osquery to having like a working prototype, and then what was the time between like having a working prototype and being able to communicate that to your customers? And I know this is just like anecdotal, but I'm just kind of curious about like, how easy was it to roll this extension?
We were very fortunate. The reason I say that is Ryan here, our VP of engineering, had an intern work on the Java packages table the previous summer, just for fun. Hey, go and do this, right? And that's what the intern did, and said, whoa, we already have the code in there. As you said, depends on the skill of the programmer and the knowledge. 2-3 days, that's not, because Ryan tells me, hey, this intern took 2 weeks or 4 weeks to write. If I did it, I would do it in 2 days. But at that time, summer of 21, we were fortunate that we were building that because we predicted that would be a problem, or it's a fun project for an intern. So it's a few days, I think.
Thank you.
We got one here back.
Between the C++, Python, and Go SDKs for Osquery, which have you or your customers found the most success with for deploying extensions or something else?
C++ is the most. And the other thing is, if you talk about Uptycs Osquery, we sometimes avoid extensions in some way because we don't it launches yet another process. So there is some pushback from customers saying, why do you want yet another process? So it's written in the very same way. It's how you compile it. You bind it in, or you leave it out as a, Osquery allows you to do that. Right? You can pull it into the same binary, or you can leave it out and talk over RPC. Right? So we use the approach of binding it into one binary. But that's our solution. General purpose, you could just write your own extension, run it as a process.
Taking the Log4j example, as you mentioned, it was very, very fast moving, and versions and some other aspects of the vulnerability itself had changed. How easy was it to not update your extension, but to kind of deploy this extension at scale to your customer environments? Is it like the Osquery agent itself needs to be updated all the time, or is it like a micro, in this case, potentially a version is an artifact, is a property that could be updated in a localized manner and so on?
So we had to update the binary once. The Osquery had to be updated once. There are, you distribute, some customers you distribute using Puppet and their own ways of doing it. And there are also auto-update capabilities where you can automatically update from our cloud. But after that, the change in version was a query change. So you change your query pack. That's all you deployed again. The fundamental nature of the problem did not change that much in a month for a new binary. It was queries.
When you compile in, it's one executable, does it still have the protections you showed us in the beginning, where it's a separate process that, how do you deal with that situation? It sounds like if it's one executable and it does bad things, you're in trouble.
Yes, correct. We're very cognizant about that. The fortunate thing is we have a large team of quality engineers and automation tests of performance and all of that, which can you run overnight across 8 different operating systems and tell us what the impact is. So that's how we were doing it. But if you didn't have those resources, the extension is a good approach where you can feel a little bit safer that your core Osquery is not impacted.
Well, alrighty. Thank you very much. Uma and Anadi, appreciate it. We're going to go on a very, very brief 2-minute break just to grab some coffee at the bathroom. If you want to come back, you don't even need to leave the room or take your seat when you return. We're going to run a quick exercise out on the patio there. Didn't bring any SPFs or sunscreen. I'm sorry about that, but hopefully you have some sunglasses. Before we break, if I could just ask our speakers to join me up front, and yeah, we'll see you again in about 2 minutes, folks. Thank you.